Hello, in this video I'm going to demonstrate a very important new feature of AvalancheNEXT, and that is multiple subnets per interface as well as virtual router support. Now, what are the advantages to both of these? First of all, multiple subnets, and you can have up to 10 subnets per test port, allows you to test with different CIDR blocks across your device under test. So you can test, for example, different subnets from the internet, small subnets, large subnets, and so forth. This adds increased complexity to your test. And what virtual routers allow you to do is basically help simplify the configuration on the device under test. So without virtual routers, if I had 10 subnets, I would have to create 10 sub-interfaces on each one of my test ports that I had configured in my test. This could be very timely and costly to actually do. So what a virtual router does is it basically front ends the client or server subnets and allows you to basically route traffic virtually across this port. So you only see one interface and one MAC address, and you only have to create one interface on the device under test. So let's go ahead and set this up. So what I'm going to do is I'm going to begin with my profile builder, and I'm going to come over here with my subnets. And what I'm going to do is I'm going to create 4 subnets, and I'm going to call them East and West, A and B. So I'm going to begin with my East subnets. And I'm going to create 99 hosts here. And by the way, another advantage of multiple subnets per port is multiple VLANs per port as well, a very important feature of this. So I'm going to call this East subnet A. And I'm going to call this East subnet B. And now I'm just going to up my address count, and you can see it's very nice because it remembers. I can just make some quick changes, and I can just keep saving off different instances of subnets. So these are going to be my West A and B. Okay, so now I've created my subnets, and like I said, potentially multiple VLANs per port too. So now if I go ahead and come over here to my virtual router, I'm going to create some front-ended routers. Now the client subnets here, they sit basically on the, you can think of it as like the left-hand side of the router. This is configuring the right-hand side of the router. So this is the interface that's connected directly to the device under test. So in this case, I'm going to call this 10.101/24. I can retag, if I choose, this traffic to a fixed VLAN or not, or just preserve the VLANs that are over here. And if I turn on MAC masquerading, what's going to happen is whatever the MAC addresses are here are going to be overwritten. So these first 2 bytes are the first 2 bytes of the MAC address of the, in this case, going to be the east side of traffic. And the last 4 bytes are basically the IP address of the interface expressed in hex. So 0A010001, for example, too. So I can keep, adding subnets, and I can still preserve my virtual router functionality. Now the other thing that I can do is I can also create static routes. So this just allows me to say, how do I get to those particular interfaces? So if I want to get to the 1.1.1.0 subnet/24, then I'm going to go through that interface on the DUT. And I can add another route as well. And it'll go through the same interface. We're going to call this East Virtual Router. And now, in this particular case, I'm just back to back between two ports. So I'm just going to make some changes here. Just flip these numbers around. And I'll call this West. And I'll save this. Okay, so I have my subnets and I've got my virtual routers all set up. Now I'm ready to actually build a test. So I'm going to come over here to my throughput mixed apps and protocols, although it would work on any of these. And I'm going to use the standard emix down here, standard load spec and pass-fail criteria. But what I am going to do is I'm going to come over and choose the appropriate queue here. And I'm going to go ahead and start dragging and dropping my subnets. So here's my East subnet. And you can see the count actually is going down. And you can have up to 10 subnets per port. So this is good. And now my B subnet. And I'm going to do the same on the other side. Okay. Now on an individual port, I can have a single virtual router. I can actually have multiple virtual routers. So if I've got 10 client ports, I can have 10 virtual routers set up. But I need to make sure that my subnets are actually sitting behind the same physical port here. So I'm going to go ahead and drag and drop my East virtual router here, and I'm going to choose this. And likewise, I'm going to come over here and choose that port to front end. Okay, so now I have everything set up, and now I can just run my test. Okay, now that our traffic is running, you basically just look at the results like you would normally look, but you can see traffic is actually routing across the virtual router appropriately across our multiple subnets, with this, this allows a tremendous amount of flexibility in terms of realism for your test. So what did we do? We created multiple subnets per port up to 10. We front-ended it with a virtual router. We turned on Masquerading, and we also turned on static routes to basically allow routes. The static routing is optional, depends a lot on the device under test, if you need that or not. This is multiple subnets and virtual router in AvalancheNEXT.